Today we're going to talk about a couple different use cases for the Scalr module registry. First off, the module registry is a library of modules. These modules are usually maintained by whether it's a DevOps team, a platform team, that are then shared out with what we call Scalr environments for your end users to then use within their Terraform code. So first off, the most basic example is that library example I mentioned. So development teams are going to log in, go to the module registry, see a list of their modules, be able to copy that Terraform code, put it into whether it's a VCS, GitOps workflow, whether they're using the Terraform CLI to develop their code and execute Terraform. The goal here is just they have a common repository or library of modules that have been approved by development, by the DevOps team or platform team to use across the organization. Second use case is being able to deploy workspaces, so Terraform and Scalr workspaces, through the Scalr UI, through the actual module registry. Now this use case is very helpful for those users who are just getting up to speed on Terraform. So they might understand some of the basics, not necessarily feel comfortable writing Terraform yet. And what this really helps with is, they log in, they select what module they want to use, click Create Workspace, fill in a couple variables, and then see the outputs and see the actual core Terraform workflow. So they get a good idea of how Terraform works, they get a good idea of the workflow, but they're not necessarily expected to write Terraform code. And this really helps bridge that gap between starting out with Terraform and becoming an expert and being able to write modules for yourself. The last use case is around controlled deployments through the provider and API. So in the Scalr provider, you can create workspaces. You can create workspaces that are also then linked to modules. And a lot of customers like this as an alternative option to GitOps because they can link these workspaces to module versions and do more controlled rollouts where they're using the provider API to update the module versions in the workspace and then kick that off through the Scalr Terraform provider or API to again have a little bit more control rather than through the GitOps approach where it's automatically kicking things off. So next we're going to go through a quick demo of each one of these use cases to show you how easy it is to do. In the first use case, we talked about using modules, or using the module registry really as a library repository of approved modules. So here you see we're in our CS-M Scalr environment, and we have a list of modules here that our DevOps or platform team has approved. Now you'll see some of them actually have the label account next to them. And what that means is that these have been created at the Scalr account scope and have been shared down with this environment so I can consume these, but as an end user I can't necessarily change them, update, really do anything except see the information around what the module is, some of the versions, whether it has submodules or not, and then essentially I can copy this code, put into my own Terraform code in my VCS repository or locally and execute a Terraform run that then uses this code. So pretty straightforward, very simple use case to get the standardized modules from the module registry. Now in the second use case, we talked about creating workspaces directly from the module registry. So we're going to use that same S3 bucket example here. And what you'll see now is that we have this Create Workspace button. Now again, this use case is very helpful for those novice Terraform users. Might not be able to create Terraform code just yet, but you at least want them to understand the workflow, how Terraform works, so that they eventually can get to that point. So we'll go ahead and click Create Workspace, and we'll put in module S3 module example. And you'll see that it's already been predefined as the source as module. It has my S3 bucket in there in the latest version. I have the option to fill in other settings for this workspace, but for now I'm just going to go ahead and create that. So upon creation, what Scalr is going to do is review the configuration that was uploaded, and it's noticing that some variables need to be filled in. So clicking on that, I see that I need to put in the bucket name. So I'll go ahead and call it Scalr demo 12345, and we'll go ahead and create and finish. And now we're essentially all set. All we have to do is click on Q new run, which is now executing the Terraform core workflow and it's going to bring us through the plan, cost estimation, OPA, policy checks, and then apply. So as you can see, with just a few simple clicks, I was able to use the Terraform module. I really didn't need to have too much expertise, but now I at least understand what that workflow is, how to fill in variables, what the output to expect, and now I'm a little bit more comfortable with Terraform so that I eventually start creating my own Terraform modules. The last use case is around control deployments. Some customers may not want the GitOps model where runs are kicked off based on a PR being merged. Instead, they want to use a module-based workspace where they can programmatically upgrade module versions when they're ready by using the Scalr provider or API. Today we are going to use the Scalr workspace to actually manage another workspace where we will define the module and the version to be used. We will make that initial deployment to create it, and then we'll upgrade that module version in a controlled way. So in the code you'll see I'm calling Scalr as the remote backend and going to use this module workspace manager as my main control plane to manage my other modules. We've set the Scalr provider. We've set what modules we want to use. So we're using an S3 bucket module, specifically going to actually use 2.0. And we're then creating that Scalr workspace, linking it to the module version, and setting a couple other settings around auto queue and auto apply. So we'll go ahead and run Terraform apply. We'll flip over to the Scalr UI here. And we see that run has already started. So we see we're creating a Scalr workspace. And now in the apply. And that workspace has been created. If I come back to my workspaces page, our S3 module deployment has already begun. And there we have it. The apply is finished and our S3 bucket has been created. Now let's say a new version has come out and we want to upgrade that module version, make the changes to that S3 bucket to be compliant with the latest version. But again, instead of doing that PR merge to automatically kick things off, we want to do so more in a controlled way. So I'm going back into my code here, and let's just bump this up to 2.1. Save that. Go ahead and run that apply again. And now what we'll see is that the run is going through to make those changes, changing that module version. Changes have completed. Now if I come back to my workspace and look at my S3 deployment, specifically go into the settings here, we'll see we've now been bumped up to 2.1. So as you can see, this is a little bit more of a controlled way of doing things. This is another use case where if you want to still do it programmatically and through the either provider API, you have that flexibility. You can link this up to any other, your CI/CD tooling to do so. But really, it's just another option for any of the other types of workflows you may have. So that's going to wrap up the demo. What we went through is the library style module, where it's really just copying code and pasting it into your own to kick off Terraform run. We went through the deploying a module through the Scalr UI for those users that are a little bit more novice. And then lastly, we went through more of a programmatic controlled rollout of modules. So as you can see, Scalr is very versatile in how we handle modules. Many different options for the many different workflows that exist out there.